Vasant sir, I think we shall start with the session.
Yes, sir, sure. We can start now. All right. So I'll share my screen. So is it visible?
Yes, sir.
Okay. So I'll just quickly take you people through the like a recap of what we did before the break. So we just started with the introduction to NI technology and LabVIEW, and we started doing some simple applications with LabVIEW. We saw what is front panel, what is block diagram. Front panel is a place where we have all our user interface taking place. Block diagram is a place where our logical code, G codes. Basically, G code stands for graphical codes takes place. So the controls are called as, the inputs are called as controls and the outputs are called as indicators. We have a palette. We have two palettes, namely controls palette and the functions palette. Okay. So when you right click on front panel, you get a controls palette and you can drag and drop all your inputs and outputs from the controls palette. Depending upon whatever data type you really want, you can just go search for it and then you can just drag and drop them. And then coming back to your block diagram, you'll have functions palette where you can right click and you can drag and drop all the functions required for your application to logically operate. Then going next, we just saw what are the different data types you have. In the screen also you can see there are like basically 4 data types plus 1, the error data type. Error is common to all functions. Okay, we can just inject error. We can also see what is the error technically programmatically happening. Okay, so we'll come back to that later, not now. Especially when we are using hardware, we'll be coming across a lot of errors. So there we'll be handling the errors. Right now we are doing simple applications, so we are just concentrating on first 4 data types. Number 1 is floating point, which is orange in color, then integer, which is blue in color, then boolean, which is green in color, then string, which is pink in color. So numerics, as I told you, are classified into 2 types, floating point and integer, where floating point allows you to enter your fractional numbers, whereas integers doesn't allow you to do that. It takes only whole number. All right. You can ask me when floating point can allow both fractional data and also whole number. Because, for example, if I talk about a number 5, which is a whole number, that can be represented as 5.00 also, right? 5.0, which is also a fractional number, 5.0. Right? So floating point can represent both. Then why integers? So usually integers restrict you to give only whole numbers. So that, for example, let me say you want to execute some items for multiple time. You can say I want to execute for 2 times or 3 times or 4 times. You can't say 2.35 times. That is not possible. If, for example, let me talk about a loop. You can ask a loop to execute 2.5 times. Let me say you want to execute one case. Either you can execute first case, second case, third case. You can't say 1.35 case. That is not possible. So there are some applications where you have to restrict the users to feed fractional data. So you have to give them only a restricted whole number. Right? That's why we have integers for. Today we saw before lunch we saw how floating point works. We saw a simple example of addition. Then we saw a simple example of gates. We saw how a simple half adder works. We saw that. Then we saw string, how a palindrome can be designed. Right? We did all these simple applications. Moving further, we'll jump into section number 3, where I'll just show you some more other features. So jumping into section number 3, I want to just introduce you one more thing. So I'll just launch my LabVIEW, file, new VI. I'll launch LabVIEW, tile them side by side by pressing Control T. Right? Fine. So now just think, I have an input. For example, I have A, I have B. All right. And I also have C. There is one more thing I want to show you people. I have C. All right. So I'm going to add all these 3 inputs together and write it on an indicator. So I take a numeric indicator. So an indicator need not be always a normal digital indicator. I can also go for example, let me say meter. All right. So from 0 to 1000, it can display. For example, I can change the level. Right? I can say even this has to be displaying -1000 to +1000. Right? We can set the levels. Okay. And if you see what is the exact value it is being representing, right click on the meter, visible item, digital display. Give a tick mark to digital display. You're getting it. Right click on the meter, visible item, digital display. Getting it. So if you wish to change the, I'll put it somewhere here at the bottom. Okay, you can move it wherever, you can design it however you want. Okay, I'm going to name it as display. Right. And once again, I'm going to show you how to change these values. Just watch out. I can just put my cursor, double click on 1000. It allows me to edit. Let me say I want it from minus 1100 to 1100. Double click, put your cursor on top of the upper limit and the lower limit and edit it the way you want. Okay. So any values beyond that, the needle will not be able to show you, but here at the representation, you will see the value. Let me say if it is supposed to show 1500, you will not be able to display with the needle. Needle has reached the limit. So you should set a proper value, but still this can display 1500 at the digital display at the bottom. You're getting it. So now I want to add these three. So I'll go for a add function. The problem with the add function is it has two terminals. Can you see? It has two input terminals and one output terminal. So I'll connect like this, and I want to connect this here. Now I'm just left out with the third input. All right. So to connect the third input, I can't do anything because all the terminals are already occupied. So if I connect like this, it will throw error. You saw this, right? This was error, which means that the wires are either not connected or it is multiply connected. It is something error. Can you see the Labio has a broken run button, which means that there is error. Can you see? The wire connects more than one data source, which means that for one destination, you have multiple source, which is not the right thing to do. So you have to delete this. So in these cases, what you can do is you can go for multiple functions. Like I'll delete this. I go for addition once again. So this will be a plus b plus c. So this will give you a plus b. The output of this function will be a plus b. This will give you a plus b plus c. This is one method of doing, so that 100 plus 50 plus 10, the answer is going to be 160. You can see that the display is showing somewhere 160. So I'll make it into, for example, 390. So the sum is going to be 500. Can you see here? So it exactly points out 500 and shows 500 here. So you can go for any type of displays. Okay, any type of display, you can just use it. This is one method of adding multiple terminals or multiple inputs to your operation. There is one more method to do it, which I'm going to show you now. Any doubt till this, anyone? This is simple. You can understand how this works. It's all about the data flow, how the data is flowing. Okay. If you want to see how the data are flowing, on the block diagram, you have a highlight execution. We were only using these functions. Now I'm just coming back to block diagram. I'll highlight this execution and run this program continuously. You'll see the data flowing. Can you see how the execution is happening? So you'll see this only if you click on the highlight execution. So you can, it helps you debug the application. So in case if your code is
Hello. I think there is a connection problem from Watson sir's end. So kindly wait for some time.
Am I audible? Am I audible?
Yes,
Yes, sir.
sir.
Yes, sir.
Yes, sir. Audible.
I'm sorry, my internet was slow and it disconnected. I hope now I'm fine now. I have stable network now. So I'll just continue with what I was
Yes, sir.
doing.
Yes, sir.
So I was trying to show you a highlight execution. So in the highlight execution, if you see, you can see the data flowing into the input and the output. All right.
Sir, your screen is not visible, sir.
Oh, I didn't share it,
Can
is it?
yes, sir.
Oh,
Yes,
maybe I didn't share it.
yes.
Yeah, thank you so much. So hope you can see now, right?
Yes, sir. Visible.
Yeah, I've just highlighted the execution. So you can see the data flowing. And if you see here, just watch. If I change this value to 200, you will see the update will be slow on the indicator. All right. So the update is pretty slower on the indicator. The reason is now it is in debugging mode where the highlight execution is on. The flow of the data is basically holded for the slower purpose for the editing. For the debugging purpose. All right. So if you remove the highlight execution, any changes you do, you'll see the update on the indicator very spontaneous, and there is no highlighting or the data is being shown on the highlight execution because the highlight execution is off. You want to on it, just click on this. So you'll see it. In normal times, leave it off. All right. In normal times, you have to leave it off. This is one way of adding multiple inputs to your code. Or the better way is I'll delete it. I'll delete all these things. I'm going to show you a better way to do this. So right click, numeric. I have add, subtract, multiply, divide, right? Something like that. I have something called as compound arithmetic. So which helps you to do any of these functions. Can you see the symbol itself represent plus, into, and or. Okay, so I'll drag and drop this here. You can see there's a plus symbol. You can right click on this function and you can go to change mode and choose whatever you want it to be working to be, right? So you can choose it to be multiplying, or you can choose it to be adding. You can choose it to be doing any of the operation which is listed out here, right? So I'll take it add. You can see that as like a normal function of addition, you have two terminals, you have connected it, but you can see there is a blue color blocks on top and bottom to resize it. Okay, I can move my cursor. You can see my cursor is now resize. I'll pull it down. I can include one more terminal now. So by this mean, I can add n number of inputs and keep on increasing it. Can you see? You can increase it. But if you use a terminal, make sure you wire it. If you're not using it, make sure you will not make it visible. Right? So now, if I change it, okay. And if I run the program, you'll be able to see it is adding with one function. Okay. So there is something called compound arithmetic, which you people can try out. So I'll save this. Is anyone trying to have hands-on? Anyone having it?
Yes, sir. Installation is going on. We will do shortly. Sir, can we add two number and subtract one number? Is there any block for that?
Possible. But you can't do it in that fashion. See, what I'll do is I'll take a new VI. I'll copy this, Control C, Control N new VI, Control T, tile them side by side, and Control V. This is how we copy paste from one VI to another VI. All right. So here, if you wish that type to happen, I'll remove the wires. I can add it. All right. The input I can add it. And once again, I have to go this method only if you are intended to do multiple operations. Right? If all these three inputs are supposed to be added, then you can go for compound arithmetic.
Correct.
So in case if you want to add two inputs and subtract the other one, then you have to go for this method only.
Okay.
Right? See, for example, let me show you like addition of, a plus b the whole square formula we have, right? So in those kind of application, a plus b, just watch, a plus b, the whole square you have to do. So the output, you can square it, right? So in like this, you can keep on adding your functions and keep on building your application. You understanding?
Yes, sir.
Right? You can see that the value is like 54,760, but the limit is only 1,100 you can display in the needle. But still you can see the values will be represented in the digital display. Getting it? So this
Yes.
is how you have to use. And in case if you have same function repeating, then you can go for the compound arithmetic. In case if it is not the case, you have to do multiple operations involved, then you have to go for multiple operators like this. Clear? So what I'll do is, I'll come back to the slide. I'll give a task, and I'll just execute a task and show you people, so that let us see how this basically works. Okay, so the exercise is converting temperature from Celsius to Fahrenheit, which means that my input is Celsius, my output is supposed to be a Fahrenheit, and you can see that I have just represented a formula for that. Okay, so F is equal to Fahrenheit. F stands for Fahrenheit, C stands for Celsius. So Fahrenheit is equal to 1.8 times the Celsius plus 32. All right, so I'm going to show you how to do this. Okay, so you're clear what is the task? We are doing some more tasks in the morning, right? Like palindrome, half adder. These are some of the tasks. I'm just including some of exercise here. So this is the exercise. So what will I do is, I'll come back to lab view. All right. So I'll just write the formula here. F stands for Fahrenheit is equal to, as per the formula, 1.8 times Celsius, which will be inside the bracket exactly. Okay. Plus 32. This is the formula. All right. So here, if you see, you should clearly notice your input is your Celsius. So what I'll do is, I'll take a numeric control. I'm going to name it as Celsius. All right. So this need not be, as I told you, need not be always a digital display. I can go for a thermometer, right? So I'll take a thermometer. I wish to have my limits. So I'll just say I want it from minus 100 degrees Celsius to plus 100 degrees Celsius, for example. All right. And this is going to be named as a Celsius. You can wish however you want, the text format, colors, everything you can change it. So I'll leave it like this, thermometer, right? So I need one more thermometer. I can copy paste, Control C, Control V. I can copy paste it, and I'm going to name it as Fahrenheit. Okay, I'm naming it as Fahrenheit. So I'll just increase the temperature. So as per the conversion, let me say if it is 100, this might go to 400. I'll just say 500 to minus 500. All right. So for both, I'm going to give a digital display. Here also, visible item, digital display. Sorry, visible item, digital display. All right. So I'll give enough space. So I have created two terminals, one input and one output. But the problem here is, by default, you can see both your Celsius and Fahrenheit, which means that your thermometer, this is the input or output. This is the input or output. Which one is input and which one is output? Celsius is supposed to be input. Fahrenheit is supposed to be output. But what do you really have here? What do you really have here? We have Celsius is the input or output here. Whatever we designed, this is designed to be an input terminal or output terminal. How it is designed?
Celsius is an input terminal.
It is supposed to be input terminal, but we have
Designed
output.
output. We have designed it as output in the left
We
side.
have designed it also output because the arrow mark shows it is a destination. The arrow mark is facing inward. Here also the arrow mark is facing inward, but the Celsius arrow mark is supposed to be facing outward, which means that Celsius currently is an indicator. It is not a control, but you want it to be a control because the input is a Celsius and output is a Fahrenheit. So the arrow mark should be facing the outward. So how to change it, I'm going to show you. So if you want to change your Celsius into a control, so right click on it and you have option change to control. So when you do that, you'll see the arrow mark has changed. I'll open the zoom again. Can you see the arrow mark has changed the other way? Yes. So any object from the palette, you can just drag and drop it simply, irrespective if it is a control indicator, you can customize it. That's the point. So even the Fahrenheit, if you wish the Fahrenheit to be a control, for example, right click, change to control. But I want it to be indicator, right? So I'll right click and I'll just say change to indicator. All right. So you can customize it the way you want. Fine. So I've created my inputs. Usually have this habit, plan what is your input and what is your output. Okay. So my Celsius and Fahrenheit are variables, so I can change them during the runtime. So I leave them as a control and indicators. Fine. So now here in this formula, you can see this 1.8 and 32. So these are all like not variables, they are constants. In the formula, you can see you have a constant 1.8 multiplied with the variable Celsius. Celsius is variable, that's why they are given as C. All right, I'm going to show you how to do that. I'll take a multiply. All right, you should not go for another control. Let me say if this was the 1.8 constant, for example, the name I'll just give us 1.8 constant, and you're supposed to type 1.8 here, correct? Or I'll just name it as constant only, never to mind about the name. Okay, so if I do something like this, right, what happens is during the runtime, we people have the tendency to make all changes. We just want to try. So let me say if you design an application like this, the 1.8 is supposed to be a constant, but if you make it as a control is the only source element we know till now. If you want to source a value of 1.8 to this terminal, you have to create a constant. I've preferred going for a control currently, which is actually wrong, I'll tell you. Okay, so now what happens is during the runtime, people might tend to change this to be like 180. From 1.8, they might change it into 180, and the output will be completely messed up, right? So if you think the particular value is a constant, don't create a control for that. Rather, you have constants to do that. So constant, I'll show you how to create a constant. A constant will never change during the runtime, and it will not be available on the front panel. It will be available only on the block diagram. So since it is not available on the front panel, the user or your client, whoever is going to use this application, will not try to change anything on the front panel. That is the ultimate idea. A constant will remain constant during the runtime. It will never be changed. If you want to change it, you have to stop the code, come to edit mode, come to the block diagram, open the source code, go to the source code, then change it. That is how we are supposed to do. All right. So I'm going to show you how to create a constant. Right click on the block diagram. I told you constants are available only on the block diagram. It is not available on the front panel. So if I want to create a numeric constant, I'll go to numeric. Excuse me. And there are two constants, numeric constant and DBL constant. These are like other constants which you don't want. This is plus infinity constant, minus infinity constant. There are other constants we have. I'm not going to use it. Which one should I prefer? Orange one or a blue one? Which one should I prefer? What do you think I should prefer? Orange constant or a blue constant? Which one should I prefer? The problem is, as I told you already, orange color represents floating point and blue color represents integer. I need a constant of 1.8, correct? So can integer be 1.8? It is a whole number, I told you, right? Integers
Yes.
can't be 1.8. You need a fractional number, so you have
Orange
to
one.
prefer
Orange
color. You understanding? So I'll drag and drop this constant here, and as soon as you drop, it will be with our default value 0. Double click on it and type 1.8 and connect it from here to here. So this is how you create a constant. This constant will not be edited during the runtime, which means that the code is running. When you click on the run button, the code will execute, right? During that time, you'll not be able to make any changes here. If the code is stopped and it is in the edit mode, you can change it. You understanding? And there is no trace of the constant on the front panel. But if you see the control and indicator, there is a trace on the front panel and also the block diagram. You have the terminals on the front panel and also on the block diagram. Whereas constant doesn't have any trace on the front panel. Right? The reason is you don't want it to be changing. It's a constant. The developer sets to be a constant and the user will never change it. All right. So Celsius into 1.8. Okay, one more thing I'll just show you. A common mistake what people do. Sometimes what people do is they don't know that you have to drag and drop this item. Rather, what they do is they'll simply double click here and type 1.8. Just simple double click. This is a free label. Whatever you can see, I've typed this. This is a free label. Like how we put it in your C program, right? You put a slash and a hashtag mark. So that will turn into a free label, right? Something like that. This cannot be connected to anything. This is a free label. Don't use a free label. Go to numeric palette. See, depending upon which constant you want. If you want a numeric constant, go to numeric palette. If you want a Boolean constant, can you see true constant and false constant? If you want a string constant, go to string constant. They have a number of string constants here, right? So I need a numeric constant. I'll drag and drop it here and just type it 1.8 and times Celsius. And now I'm supposed to add it, right? What should be here? The added, what is the other value here on this terminal? It is supposed to be 32, right? Now, even this 32 is a constant, correct? So should I use orange color or blue color this time? Logically, should I use orange color or blue color?
Blue will do.
Blue will do our task, right? So if I use a blue color, this is a whole number, sorry, it's a whole number where I type 32, I'll connect it, and I'll connect it from here to here. All right, this will do the task, right? So if you want, I'll just test the code. Let me say 36 degrees Celsius. We can see it is 96.8. It's a room temperature. I mean, sorry, body temperature, 96.8, regular temperature. Okay. If I say 25, we can see 77. I can even give negative data. Negative 10 degrees Celsius, it is 14. Minus 50 degrees Celsius, it's minus 58 here. Getting it? Celsius to Fahrenheit conversion. This can be anything. It can be from like centimeter to feet, or currency conversion, like Indian rupees to other, US dollar or UK pounds. It can be anything. All right. So it's up to you. But here, one more thing I want. Any doubts in this till now? Anybody? How it is done? Is it simple?
Yes.
It's simple, right? Fine. Here, I'll come back to your application here. If this is clear to you, I want to bring you people to notice that when everything was orange in color, this particular 32 constant was blue in color. And you can see there is a red color dot, right? This red color dot in LabVIEW is called as a correction dot. Correction, C-O-E-R-C-I-O-N, correction dot. It means that the LabVIEW is trying to somehow manage the data type mismatch, because this terminal, just talk only about the addition function, it has inputs to be orange and output to be orange, because it takes input of orange color and gives output of orange color. All right. But all of a sudden, he experienced a blue color data type, which is a float, which is a integer data type. So he was stunned. But still, what happened is LabVIEW, since it is like high-end programming, it has managed to do the conversion, and that conversion has internally used a buffer, and that buffer, which means a memory unit. Okay, a buffer is converting this 32 data from integer to a floating point, and then using a floating point internally. So whenever you see a correction dot, which means that you have connected a wrong data type, and LabVIEW somehow is managing. Always avoid a correction dot. Always avoid a correction dot. So if I want to avoid the correction dot here, what change I'm supposed to do here? What change I'm supposed to do here?
Convert it to orange.
Come again?
Convert to orange again. Maybe.
Beautiful. Rather than this, it should have been an orange color data type. So everything is going to be orange color, and it's going to be fine. So to do this, you don't have to delete it. Rather, I'm going to show you how to change the data type. Right click on this particular 32. You want this to be orange color, right? So you can come to representation. You can see now it is currently integer 32-bit integer. The I64 means integer 64-bit. U64 means unsigned integer 64-bit. I8 means signed integer 8-bit. U8 means unsigned integer 8-bit. Okay. I'm supposed to select DBL. So DBL means orange color. We know that, right? Double position floating point, DBL. So you can see here, you can see now it is orange color. You can closely see it. I'll zoom in. You can see there is no correction dot further. All right. Now, if I run this program, if I slide the cursor, can you see I can even slide it like this? For any values I represent, let me say I'll leave it for somewhere around 40. The output is 104. Getting it? Yes?
Yes.
This is one simple application. The reason why I'm saving it is in case if you want it for further use, you can just ask me, I can give you. Okay. Just a minute, I think my battery is low. There's a power shutdown here. That's a problem. My internet was also having a problem. In case if it shuts down, you can go for a break. Okay. just go for 10-15 minutes break. Meanwhile, I'll just switch to different computer which has battery, and I'll get back to you. All right. So I think it will last for like 5 minutes. All right.
Yes, sir.
So after the finishing this around 3 o'clock, maybe we started a little late. I know, we started by 2:15, but the problem is I have a power shutdown here. That's the problem. I can't recharge the laptop here. So let it go on. But finishing this, we'll go for a 10-15 minutes break. I'll replace the laptop also and get back to you.
Yes, sir.
Okay. Yes. Fine. So if this is clear, I'll take a new VI. So with this, I'm going to show you a different thing. Okay. So I'm going to quickly jump into a application which is like more going to use a structures. I'm going to show you what is structures and how to use structures. All right. So there is a palette which is very much responsible for holding all your structures. So inside this, you can see there is for loop, while loop, time loop, and you also have, case structure, event structure. There are n number of structures you have. Structures are nothing but they are the fundamental element of design. So if you want the application to be looped, iteratively execute again and again, then you can go for these kind of applications. All right. Yes. Like this, I'm going to use a case structure currently. So what I'll do is I'll quickly design you an application of the same palindrome. Okay. I'm going to say palindrome input. So I can type the data here. I'll do the same application of, I'm making it case sensitive, let it be case sensitive, not issue. Okay. I'll say reverse. We saw this morning, right? I'll use equal to. Okay. Fine. This is okay. We have done this. And this will give you true or false, correct? So yes, they are same, or no, they are not same. Now I want the output to be a string indicator like this, which says it is palindrome or not palindrome. You need a textual status. Yes, palindrome, no, not a palindrome, something like that. Okay. So I'm going to name it as output. Okay. So whereas if I connect from here to here, you can see there is a broken arrow. If I touch on this, it says you are connected two terminals of different data types. The source is Boolean, true or false, and the syncing is a string. So you can't connect it. So in this case, what I'll do is I'll right click, comparison. I go for a function called a select. I'll quickly explain you how the select works. Just watch. I'll drag and drop here. So here you can see the center terminal is a Boolean which selects you want either true or false. The top terminal or up terminal is called as a true, and the bottom terminal is a false. I'm going to take a string constant. Okay, I'm going to name it as yes palindrome. Care about the spelling. Okay, I'll copy paste here. This I'm going to name it as no. This is the textual data I want to display. Okay, I'll connect it here and I'll connect this output here. So now what happens is if this is true, depending upon all the calculation, if this was true, this terminal, this wire was true, you can see here there is a T. This data, top data is connected to true, and this data will pass out. If it is false, this particular data will pass out. It's more like your switches in your mechanical model, or even in your electrical model. If you see, there are switches where depending upon 5 volt you pass, or high or low volt, either this signal will come out or this signal will come out. This is more similar to that, right? So now if I say madam and run this code, you can see that it says yes, it is a palindrome. I'll make it slightly bigger. It says it is a palindrome. You can see here, madam, reverse is madam, true is passing. So whatever is in the upper terminal is passing out. If I say madam, you can see same. Now false will pass out and not a palindrome is being displayed. You understanding this? So now you have two set of logic that can reach your output. depending upon what you pass as an input here, that particular value is passing out. So this is a simple decision making. Whereas it has to display this message or this message, it is making a decision by manipulating, computing. Right? I'm going to show how to do this in a larger level. So it is going to shut down now. So it's 2 minutes left out. 7% I have. So that we are going to shut down now. So what we'll do is we'll just go for a break. It is already 3 o'clock. We'll just go for a break. We'll come back in 15 minutes and we'll continue with the higher level. Any doubt in this? If you have any doubts, just mark it out. I'll go for it. It's going to shut down. Then the connection is also going to get lost. Let it go till how much ever it can. And then I'll just replace the system. All right. Fine. Any queries how this particular function works? This name of this function is select. You right click, comparison. We used equal, right? Below that you have select. It takes a Boolean input and a S terminal message, no terminal message. And depending upon you pass true, the one the top will come out. If you give a false, that particular bottom value will come out. Hope it's clear.
Yes, sir.
Yeah, fine. We'll just break it now and we'll get back in 15 minutes. I'll come up with a different computer. All right.
Yes, sir.
Sure. Thank you, everyone. We'll just break for now.